Welcome, everyone, to today's Explainer. I am absolutely thrilled to have you here. Think of me as your enthusiastic professor as we jump right into a fascinating journey to uncover the absolute bedrock of modern technology. Today, we're diving into the binary foundation of computer intelligence. We're going to explore exactly how computers and AI communicate, quite literally from the ground up.
So let me start off by asking you this. Why do computers only use two numbers? Think about it for a second. As humans, we communicate using these rich, complex languages. English, Sinhala, Tamil, the list goes on and on. But computers, they're an entirely different beast. They rely completely on a stripped-down, super basic language consisting of just two numbers, 0 and 1.
Okay, let's dive into this. Here is our roadmap for today. We'll kick things off with the language of computers and the hardware that actually runs it. Then we'll move right into translating and processing that data. Finally, we'll wrap up with binary's role in artificial intelligence and modern tech. So we're going from a microscopic signal all the way up to complex AI.
Let's get started with Section 1, the language of computers, decoding the machine.
The absolutely crucial point here is understanding what we actually mean by binary language. It's simply a number system that uses only 0 and 1. You and I were totally used to the decimal system, right? We count with digits 0 through 9. But the second you go inside a computer, that human logic just goes out the window. Everything, and I mean absolutely everything, is processed using just those two tiny digits.
Moving right along to Section 2, hardware and the transistor. This is where we look at the physical reality of it all. Okay, so computers are electronic machines, right? And to process this binary language, they need physical hardware. Enter the transistor. A transistor is essentially just a tiny electronic switch inside a computer. And when I say tiny, I mean genuinely microscopic. To put that into perspective, the smartphone sitting in your pocket right now contains billions of these tiny electronic switches packed onto a single tiny chip, all working together to process signals. And this brilliantly illustrates how those tiny switches actually function. Think of a standard light switch on your wall. A light switch really only has two definite states, right? It's either on or it's off. Well, electronic systems work best with these two simple states. So a transistor constantly switches back and forth. The number 1 represents on and 0 represents off. It really is that simple. Which brings up a pretty interesting question. Would simpler systems work faster? Why do computers prefer just two signals instead of counting 0 through 9 like we do? Well, it's because processing just two states, on and off, leaves literally zero room for ambiguity. It's so much less prone to electronic noise or interference than if a machine was trying to read 10 different voltage levels. It allows the hardware to process information with incredible reliability and at lightning speeds, all without making those pesky calculation errors. Let's jump into Section 3, translating data into binary, encoding the world. It is fascinating to see how this translation actually looks in practice. If we compare standard decimal numbers to binary, 0 is 0 and 1 is 1. Simple enough. But look what happens at the decimal number 2. In binary, that becomes 1, 0. 3 is 1, 1. 4 is 1, 0, 0. Now, I know it looks a bit alien to us for sure, but I really want you to see that binary represents exact, precise mathematical values, exactly like our decimal system. It's just a different way of counting. But here's the thing. It's not just about crunching numbers. Computers convert literally everything into binary. Every single letter of the alphabet, like A or B, every symbol, every high-res image, every piece of streaming music, and yes, even your favorite emojis. They are all assigned a specific, unique binary code. This translation is exactly how a computer is able to store and display the text you're reading on a screen. The entire digital world inside your device is just this massive, complex combination of zeros and ones. Let's ground this in something you probably did right before starting this explainer, sending a text message. First, your typed words get converted into binary code. Second, your phone processes that binary data using its transistors. Third, the message gets sent digitally across the network. And finally, your friend's device receives it and converts it right back into readable text. What's mind-blowing is that this entire multi-step digital translation happens across the world in mere seconds. All right, Section 4, processing digital instructions, following the recipe. It is absolutely vital to understand that computers do not think the way you and I do. They operate entirely through programs. And a great way to wrap your head around this is the chef analogy. A computer acts like a chef who must follow a recipe perfectly. It follows instructions precisely step by step, it never guesses, and it processes commands logically. A software program is literally just a massive recipe made of millions of binary instructions that the computer chef follows blindly.
To see this chef analogy in full swing, just look at video games. When you're gaming, there is massive scale binary processing happening simultaneously. Binary instructions are controlling your character's movement. All those stunning graphics, yep, processed using binary data. The immersive sound effects are stored digitally, and even your AI opponents are just following programmed instructions. It's billions of ones and zeros all following the recipe flawlessly.
Now for Section 5, Binary and Artificial Intelligence, the Illusion of Thought. Now, what's really interesting about this next concept is how AI pulls off its magic tricks, like image recognition. If an AI system is trying to identify a cat in a photo, step 1 is converting the image into digital binary data. Step 2, it rapidly analyzes patterns in those zeros and ones. Step 3, it detects shapes and features mathematically. And finally, Step 4, it predicts whether the image actually contains a cat. The ultimate takeaway here, even the most unbelievably complex AI image recognition is fundamentally just crunching binary data extremely fast. I really want to reground us in this core concept for a second. Even though AI appears incredibly intelligent, honestly almost human sometimes, deep down, everything becomes binary data, relying entirely on electronic signals. No matter how magical an AI tool seems, it only works by processing billions of electronic on and off signals per second. Let's bring it all together in our final section, the foundation of modern tech and why binary actually matters. The power of binary systems genuinely cannot be overstated. It completely simplifies computer design, which makes hardware production practical in the first place. It increases the reliability of our devices and drastically improves processing speed. It allows for huge amounts of digital storage, and, as we just discussed, it's the bedrock that supports modern AI systems. Quite simply, without this basic foundation, the internet, your smartphone, cloud computing, none of it would exist. I want to share this quote directly from the source material because it perfectly cements our ultimate takeaway today. Behind every app, game, website, and AI system is a simple language built from just 2 numbers, 0 and 1. It's almost poetic, isn't it? How something so brutally simple creates absolutely everything digital around us. Okay, before I let you go, I've got a quick activity for you. Consider it your homework for this explainer. I call it Binary Around You. I want you to choose 3 digital devices that you use daily. For each one, explain what it does, describe how you think it relies on binary processing behind the scenes, and try to identify one AI feature it might contain. I challenge you to apply today's lesson to the devices sitting right there in your own home. And I'll leave you with this final provocative question to ponder before our next lesson. Is computer processing actually similar to human thinking? We've seen how machines process ones and zeros at lightning speed to simulate logic and recognize patterns, but is that truly thinking? I'll let you chew on that. Keep asking questions, keep exploring the tech around you, and I will catch you in the next explainer.